Hey guys, we're just in the middle of our gauntlet making series, our gauntlet project for the infantry harness, and we're just having a little quick chat about hammer rolling and the ideas behind work hardening and what that means for the material and why we do it and what does that impart upon the steel. Hardening is the process by which iron or steel is taken from its natural state, where it is both soft, malleable, ductile, easily deformable, and through processes it is made hard, which means it is brittle, rigid, and resistant to movement and abrasion. In armor making, we want the material, the armor that's going to be stopping swords and axes and knives in combat to have the property of hardness so that it retains its shape when it's struck and turns away the edges of weapons in combat. Essentially, we don't want that armor to dent, break, or deform, injuring us, the wearer of that armor. So hardness and toughness is a really big and important part of armoring. And there's two main ways that we generate hardness in a material, or springiness in a material. One is the thermal hardening process, and the other is work hardening. The thermal hardening process is the most commonly recognized process for hardening material. It's the process of heating up the metal to critical temperature and then quenching it into water and oil to harden up that material. Brings the carbon molecules quickly into the iron lattice and makes it rigid. This file is a good example of a piece of steel that's been hardened by that process. It's rigid, it's brittle, incredibly abrasion resistant, really good for filing and stripping things down, really bad for armor. Incidentally, in armoring, after this hardening process, we temper the piece, which brings back the springiness into it. But when we're working with a material like mild steel, which we're using for this build, it doesn't have enough carbon in it to generate the kind of hardness required to even get spring steel. That's because there's not enough of the carbon molecules to trap between the lattice for it to get the toughness that we require. So we rely on the second method of hardening, which is work hardening. Work hardening is essentially the process by which we remove the isolations or the gaps between the iron molecules through hammering it and working it throughout the making process, which removes its opportunities to move and resulting in something that has rigidity, structure, and actually a little bit of springiness, not that dissimilar to its spring steel counterpart. In our gauntlet making process, where all of this becomes relevant is in shaping a piece like this, the cuff or the vambrace component of our gauntlet, and it's a round shape, more or less. And there's two main ways that we can approach that utilize the idea of work hardening. One is to just bend the material around a stake or the horn of the anvil, and the other way is to hammer roll it, or work the material with a crossbeam hammer with many hammer blows to bring it around into a circle. This second technique makes great use of the work hardening process, giving a really rigid and solid piece as opposed to bending the material, which leaves a lot of room for extra movement in the piece later down the track and is not as consistent nor as precise in how it brings about the shape we require. Work hardening is basically taking away the opportunities for bending in the material. It's like a cat has 9 lives. The steel has 9 opportunities to bend. By doing all the bending already, it's used up its ability to bend anymore, so it wants to resist. It doesn't want to do any more bending. It's sick and tired of bending, and so it stays rigid in the shape that you've created it in.